Hope you have gone through part 1 and part 2 where I deduced the initial law of creation and the present age of the cosmos. Also hope you have understood part 3 where I stated the shape of the cosmos. In this part I shall discuss about the characteristics of a black hole. This is a section of our cosmos as per alternate estimation of its age, which has been discussed in part 2 and part 3. We shall now determine K of Jupiter and K of Europa, which is a satellite of the Jupiter. K of Jupiter. Average orbital velocity Vj of Jupiter is 13.07 km per second. Average distance dj of Jupiter from Sun is 77.8547200 km. By equation 3, K1, which is a constant, is equal to Vj square dj, or K1 is 1.33 into 10 to the power 11 km cube per second square. Now K of Europa. Average orbital velocity Ve of Europa is 13.74 km per second. Average distance dE of Europa from Jupiter is 670,900 km. By equation 3, Kj, which is a constant, is V square dE, or Kj is 1.27 into 10 to the power 8 km cube per second square. From these determinations, we find that K1 is nearly 1000 times larger than Kj. If this relationship is given cognizance and the value of K1 is taken as the yardstick to establish a sequence, we can draw a table of K for Q cosmic bodies. Escape velocity of a body from the surface of a cosmic body is V escape is root 2 gr, where g is gravitational retardation of the body and r is the radius of the cosmic body. Or V escape square is 2 gr, or V escape square is 2 gr square by r. But by equation 4, gr square is k, therefore r is 2k by V escape square. In other words, the minimum radius of a cosmic body necessary for a particular body to escape from the surface of the said cosmic body is 2k by V escape square. Therefore, if Vl is the velocity of light in space, the minimum radius of a cosmic body necessary for light to escape from its surface is 2k by Vl square, and the cosmic body is seen as a shining star. Therefore, R minimum is 2k by Vl square. Hence, the necessary condition for a cosmic body to shine like a star is present radius of the cosmic body must be equal to or greater than its radius at which velocity of light is equal to or greater than the velocity necessary for escaping from its surface. By equation 12, minimum radius r1 of the Sun necessary for light to escape from its surface is 2k1 by Vl square, where k1 is the constant for Jupiter and other solar planets, which is equal to 1.33 into 10 to the power 11 km cube per second square, and Vl is the velocity of light, which is equal to 2.9979258 into 10 to the power 5 km per second. Therefore, R1 is 2.95964915 km. As per table 2 in part 2, present radius of the Sun is 695500 km, which is much larger than R1. Therefore, the Sun now shines as a star. From table 2 in part 2, radius of S6 is 10 to the power 5 into radius of Sun. By equation 10, T is Cf into radius of S6 square, which is equal to Cf into 10 to the power 5 into radius of Sun whole square. Or time taken by light to escape from the surface of Sun since its birth is 8.76 into 10 to the power 10 seconds. So, Sun started shining after attaining a radius of 2.95964915 km in 87.6 billion seconds after its birth. Similarly, by equation 12, minimum radius R2 of QS2 necessary for light to escape from its surface is 2k2 by Vl square, where k2 is a constant for Sun, which is equal to 1.33 into 10 to the power 14 km cube per second square, and Vl is the velocity of light, which is equal to 2.9979258 into 10 to the power 5 km per second. Therefore, R2 is 2959.64915 km. As per table 2 in part 2, present radius of QS2 is 6955000 km, which is much larger than R2. Therefore, QS2 now shines as a star. From table 2 in part 2, radius of S6 is 10 to the power 4 into radius of QS2. By equation 10, T is Cf into radius of S6 square, which is equal to Cf into 10 to the power 4 into radius of QS2 whole square, or time taken by light to escape from the surface of QS2 since its birth is 8.76 into 10 to the power 14 seconds. So QS2 started shining after attaining a radius of 2959.64915 km in 87.6 trillion seconds after its birth. By equation 12, minimum radius R3 of QS3 necessary for light to escape from its surface is 2k3 by VLS square, where k3 is a constant for QS2, which is equal to 1.33 into 10 to the power 17 km cube per second square, and VL is the velocity of light, which is equal to 2.9979258 into 10 to the power 5 km per second. Therefore, R3 is 2959649.15 km. As per table 2, present radius of QS3 is 69550000 km, which is much larger than R3. Therefore, QS3 now shines as a star. From the table 2, part 2, radius of S6 is 10 cube into radius of QS3. By equation 10, T is Cf into radius of S6 square, which is equal to Cf into 10 cube into radius of QS3 whole square, or time taken by light to escape from the surface of QS3 since its birth is 8.76 into 10 to the power 18 seconds. So QS3 started shining after attaining a radius of 2959649.15 km in 8.76 into 10 to the power 18 seconds after its birth. By equation 12, minimum radius R4 of QS4 necessary for light to escape from its surface is 2k4 by VLS square, where k4 is a constant for QS3, which is equal to 1.33 into 10 to the power 20 km cube per second square, and VL is velocity of light, which is equal to 2.9979258 into 10 to the power 5 km per second. Therefore, R4 is 2959649.150 km. As per table 2 in part 2, present radius of QS4 is 6955000 km, which is much less than R4. Therefore, QS4 does not shine as a star now. Black cosmic body at the center of our galaxy. Present radius of QS4 is much smaller than the radius necessary for light rays to escape from its surface. So QS4 looks black. It cannot be called a hole because it's a cosmic body. Core of the Sun. Sun was a black cosmic body when its radius was less than 2.95964915 km. Therefore, light particles residing within a sphere having radius of 2.959649 km around the center of the Sun can never escape boundary of this sphere. We may call it the dark core of the Sun. Dark cores of stars. Similarly, spheres having radii of 2959.649 km and 2959.649 km around the centers of QS2 and QS3 respectively are their dark cores from where light particles can never escape. All stars in the cosmos were black cosmic bodies at different times during the expansion of the cosmos. Therefore, they have dark cores within them. By equation 3, velocity v4 required presently by a particle for orbiting around the surface of QS4 is root k4 by r4, where k4 is 1.33 into 10 to the power 20 km cube per second square and r4 is 6.955 into 10 to the power 8 km. Therefore, v4 is 4.373 into 10 to the power 5 km per second. Therefore, v4 is greater than the velocity of light in space. Spherical shell of accretion around QS4. Therefore, the light particles coming from all directions and passing through the vicinity of QS4 are accelerated. They revolve around QS4. A bright rotating spherical shell of light particles is formed around QS4. QS4 is almost covered due to accretion of light particles. The only uncovered parts of QS4 are tips of its polar regions. By equation 11, the present escape velocity from QS4 is V escape is equal to root 2k4 by r4, where r4 is present radius of QS4, which is equal to 6.955 into 10 to the power 8 kilometer, and k4 is 1.33 into 10 to the power 20 kilometer cube per second square. Therefore, V escape is 6.18432 into 10 to the power 5 kilometer per second, which is over twice the velocity of light. So, light particles cannot escape from the gravitational field around the tips of poles of QS4 and reach us. Tips of poles are seen as dark holes wherefrom no light particles escapes. Every light particle of the spherical shell of accretion orbits around QS4 with a velocity between 2.9979258 into 10 to the power 5 kilometer per second and 4.373 into 10 to the power 5 kilometer per second. Light particle that orbits on surface of QS4 has a velocity of 4.373 into 10 to the power 5 kilometer per second. Light particle that orbits on outer surface of accretion shell has a velocity of 2.9979258 into 10 to the power 5 kilometer per second. By equation 3, d4 is k4 by VL square, where d4 is equal to xb as in the diagram, which is the distance between center of QS4 and a light particle at B, and k4 is 1.33 into 10 to the power 20 kilometer cube per second square, and VL is 2.9979258 into 10 to the power 5 kilometer per second. Therefore, d4 is 14.79824575 into 10 to the power 8 kilometer. But by table 2, xa is equal to 6.955 into 10 to the power 8 kilometer. Therefore, thickness AB of spherical shell of accretion is equal to xb minus xa, which is equal to 7.8432455 into 10 to the power 8 kilometer. Light particle traverses directly from a star to one of the exposed polar tips of QS4. It falls on the surface of polar tip with accelerated velocity due to huge gravity of QS4. It bounces back in the same direction to space. The bouncing acts of light particles on the exposed polar tips of QS4 are continuous processes. Hence, we see jets of lights from polar tips of QS4 to space. We call these bipolar jets.